Okay, let's set the controller, PCB and fan apart and concentrate on the transformers. You can see there the two primary windings are connected in parallel and are driven by the triac directly from the mains voltage. Make sure you choose the correct phase when you parallel the primaries. Anyway, it's easy and non-destructive to test if you have got the good phase or not, because if the wiring is wrong, it will just read almost 0 volts on the secondary. If this is the case, just reverse one of the primaries and you'll get your 3.4, 3.5 volts straight away. Now, as far as the zero crossing detector is concerned, I could have seen it coming, but in fact I didn't. So I had to add this thingy afterwards. Well, it turns out that when you pulse drive a transformer, you have to make sure that the number of positive semi-periods in its driving cycle matches exactly the same number of negative semi-periods. If you don't do this, you will end up with a saturated core and huge primary currents, which in the best case will cause your mains breaker switch to go off, or it will produce extreme overheat in your primary winding. So in your schematic and your drivers program, you'll have to have some means to synchronize the start and stop pulses with the mains zero voltage crossings. Well, that's about it. I didn't bother taking apart the power supply because it's just a standard plus 5 plus 12 volts switching power supply. If you're interested in zero voltage switching a triac, I can email to you my schematic and the source code of my C program, together with some considerations for power and timing selections. The alternative to zero voltage switching would have been hard switching the triac using phase modulation, or hard switching an IGBT. And I didn't go for this solution because, with over 20 amps currents, the thing would have been too much, how should I say, electrically noisy. And finally, let's put it to work. Here I have some 2mm diameter low carbon steel rods. These are easily cut in half if the power is too high or the welding time is too long. I've set the power to 50% and the pulse length to 280 milliseconds. So let's see how it works. Okay, so it's welded quite well. Let's make another point here. Yeah, it looks pretty good. Okay, now this is a round mild steel pipe. I remember this came from the stick of a broken umbrella. Very thin material. Let me try to weld a steel rod on it. Here the power is set to 100% and the pulse length is 400 milliseconds. Let me put some gloves on because I have to hold this piece of metal together. Okay, let's get rid of the plastic chip. Let's see what happens here. Yes, I guess. Yeah, I guess this is quite solid. Excellent. Now, these are two steel sheets. One is stainless steel, quite thin, 0.4mm thickness, and the other one is mild steel, low carbon, slightly less thick than 1mm. I think it's 0.9mm. Power here is set at 90% and post length is 480 milliseconds, about half a second. I've polished the two surfaces. Let's see what it does. Here. Okay. That looks quite, yeah, that looks very good indeed. Yeah, there's no way to take it out. Okay. Here are two pieces of bare iron. One is 2.2 millimeter thick and the other is exactly 1 millimeter. I'm going for a manual welding now and try to see what is the best compromise for post length. Let me start with 50% power. Okay, where is the polished area? Here. Okay, let's give it a try. Okay, it looks pretty much welded. Let me grab pliers. Okay, looks good to me. Let me see. Yeah, definitely. Oh no, that was not enough. Let us give it another try, maybe higher power. Let me see. So now this is 100%. Again, still in manual mode. Let us give it another go. Okay. Let's see what it does. Yeah, now this one, I think it has done the job. No, there's no way to take it apart. So 100%, and the timing, I'm reading it's 1.4 seconds. So if I had to do multiple weldings on this same couple of materials, I just select preset welding and enter these exact values, which is 100% power and 1.4 seconds. Now these are again two different pieces of plain iron, both polished with a file to make the surfaces clear from oxide and paint. I'm again welding in manual mode, 100% power, and let's see what it does. Oh, there's a hole in here. Yeah, I'll just set it aside. Okay, let's see. I think that's enough. Looks good to me. That was, yeah, it is indeed. It's, yeah, it's, well, it's an excellent weld, I should say. And what it was, 1.68 seconds. Again, 100% power. And now, this is a stainless steel, a quite thin sheet of stainless steel, and I'm trying to weld it on a quite thick piece of iron. This one is almost 3 millimeters thick. Again, working in manual mode, 100% power. Let's see what it does. Okay, here. Good. Let's see. Yeah, looks good. It does look quite good, yes. It's, let me see if I can break it apart. Yes, I can break it apart, but as a matter of fact, it creates a hole into the
stainless steel because this sheet of metal is so thin. As a matter of fact, the actual welding spot was holding quite well. Timing here was, let me see, 2.44 seconds, still at 100% power. Now this is interesting. It's a square stainless steel pipe, and I'm trying to weld a piece of chrome plated iron onto it. Here I've polished the two surfaces. Let's see what it does. Always in manual mode. Oh yeah, they barely fit under the electrodes. Let's see. Okay. Let's see the result. Yeah, it looks quite a good weld. Let's see the mechanical. Yeah, it is definitely welded. I managed to detach it, but if you see, along with the piece of iron, I've stripped off also a piece of stainless steel, so I should say the weld was quite good. Finally, this is gonna be a tough one. Here I have a 2.5 millimeter iron part of a lock and a 7 millimeter diameter iron rod. I know spot welding isn't the suggested welding strategy for this type of materials. I should go for stick welding or brazing, but you know, just for the sake of trying, let's give it a shot and see what happens. Okay. Let's see. Okay, this was a long shot, 4.2 seconds roundabout. Let's see. This is the result. Current has been flowing through the two metals, that's for sure. And yeah, no, that was not enough, but still I had to apply quite some force to detach it, but again, I don't think this is the correct welding strategy. The fact that the welding was so weak is, I think, mainly due to the high mass of the two materials, the two pieces of metal, and also due to the fact that the dissipation of the heat is too high, so the temperature here didn't reach the correct value. So just a little bit of the two metals actually melted together, so the welding was surely not strong enough. Okay, so this is as far as it goes. If you have comments or suggestions, please drop me a message. It'll be a pleasure. Thanks for watching.